Hello semua, good evening. Can you hear me? If you can hear me, can you give a shout out in the live chat? Good evening everyone. Cuba bagi dulu shout out in the live chat if you can hear me. Thank you Evani, thank you Lol Z, thank you Irfan Izzuddin, thank you Dion. Alright. Okay, so good evening everyone. So welcome to our siri pensyarah kimia awak ke bintang ke babum. Gitu kan. Episod yang pertama dan kali ini kita akan bersama dengan seorang pensyarah yang begitu hebat dengan Miss Jana. So Miss Jana akan membantu kita semua untuk recap dan cuba memahamilah konsep-konsep yang penting yang ada dalam physical properties for organic chemistry. So the reason why we want to have this open lectures open to all is because this is our inisiatif untuk membantu kamu semua menghadapi peperiksaan yang tidak lama lagi. Less than 1 month kan you're going to have your PSPM examination. Okay, so without further ado, saya mempersilakan kita punya first facilitator for episod pertama SPKA ke bintang ke babum. So over to you Miss Jana.
Hello, hi. Good evening everyone. So hari ini basically kita akan cover on the concept of physical properties and kita akan tengok in terms of boiling points, solubility and acidity. Okay, so this is the questions yang kita akan cover for tonight. So kita akan cover some bits in terms of boiling points, solubility and acidity. So let's take a look at the general idea macam mana kita nak fikir ataupun what are the things yang kita kena consider when we discuss about physical properties. Okay, so as what you have learned previous semester in SK015, for sure you aware the fact that kalau kita nak tengok the strength of physical properties such as boiling point and solubility, kita akan always refer back to the idea of intermolecular forces. Okay, so you jumpa 3 jenis intermolecular forces last semester, which is first one, the famous ever hydrogen bond, of which untuk molecules tu ada ability untuk possess hydrogen bond. Dia mesti ada hydrogen that bonded to top 3 most electronegative atom, which is either fluorine, oxygen ataupun nitrogen. Okay, and another type of intermolecular forces yang you akan jumpa adalah dipole-dipole forces and London dispersion forces. Okay, but this time usually kita akan compile these two together under van der Waals forces. So these two ataupun forces yang you ada ni, the strength of intermolecular forces yang you jumpa will actually affect the physical properties of the molecules. So dia akan affect boiling points and solubility. So macam yang you dah jumpa juga last semester in terms of boiling point. Boiling point is basically point at which you punya atmospheric pressure, you punya internal pressure equalize atmospheric pressure, tapi dia macam a bit lengthy. But to make things easy, actually sangat senang untuk korang just visualize on temperature at which you punya liquid ataupun aqueous molecule can convert to gas. Okay, so what happened here, basically we're going to break the intermolecular forces. So ada lagi banyak spaces between molecules you. So that's why dia punya change instead of matter happen. Okay, and the thing is you should know kalau you ada a weaker intermolecular forces. So a weaker intermolecular forces will means sangat senang untuk you break the intermolecular forces. So that means, sorry, kat sini ada correction. So that means boiling point of molecule you pun jadi rendah. Okay, so sangat senang untuk you convert daripada liquid aqueous to gas. So lagi senang untuk you convert means you ada a weaker intermolecular forces. Okay. But for solubility, actually it's a bit difficult for you to imagine in terms of solubility sebab mata kita tak boleh tengok macam mana solubility works. But to make things easy, actually you can just imagine on how you punya molecules that we interested in actually ada ability tak untuk form intermolecular forces with the solvent molecule. Okay, so contohnya kalau kita guna water as our solvent, so adakah you punya molecule can form hydrogen bond with water? Ataupun kalau you nak guna benzene as your solvent for example, so adakah you punya molecules can form van der Waals forces with benzene molecule? Okay, so basically you can say that solubility also refer to the ability of your molecules to form intermolecular forces with solvent molecules. Okay, so that is the general idea that you should have in terms of intermolecular forces. So by that, let's take a look at the first questions that we have for tonight. So the first one here, kita ada 4-ethyl heptane and then 2244 tetramethyl pentane and nonane. So for this one here, we need to arrange you punya alkanes in here in the order of increasing boiling point. So maksudnya, you kena susun you punya molecules kat sini daripada lowest boiling point to a higher boiling point. And the thing is, the first thing you kena check bila mana you ada soalan macam ni, kira number of carbon that involved in your compound. Okay, paling senang you just briefly check je berapa number of carbon yang you ada. So kalau kita tengok kat sini, you punya backbone chain kat sini kita ada heptane, so maksudnya kita ada 7 carbon. So and then dia ada substituents of ethyl group dekat carbon nombor 4, so that means kita tambah lagi 2 carbon. So you ada a total of 9 carbon. Okay, and the same goes with 2244 tetramethyl pentane. So backbone dia ada 5 carbon pentane, and then kita ada 4 methyl group. So 5 campur 4, obviously you dapat 9. And then for nonane, kita ada straight chain linear 9 carbon. Okay, so the thing is, each of them have a 9 carbon. And one thing for sure, you can aware the fact that van der Waals forces is actually hugely affected by molecular weight ataupun molecular mass. Okay, and cara paling senang untuk you figure out the mass of your compound, kira je number of carbon yang you ada. But for this one here, since number of carbon tu semua sama, that means ada factor lain yang you kena consider. And bila mana you lukis structure yang you ada, sebab actually it is pretty difficult for you to visualize you punya structure kalau you dapat nama molecule you. So paling senang, convert the name of the molecule to the structural formula first. So by this, I think it's pretty clear to you, walaupun kesemua 3 compound yang kita ada kat sini consists of 9 carbons, but each of them have a different structure. Okay, so untuk 4-ethyl heptane kat sini, kita ada 7 straight chain and then kita ada 1 branch kat sini. And then for 2244 tetramethyl pentane, for this one here, kita ada substituent dekat carbon nombor 2 dan juga carbon nombor 4. And then for nonane, we have a long linear chain. Okay? And one thing for sure, you kena ingat, another factor that you kena consider for van der Waals forces is how big your surface area in contact with another molecule. Okay? You can imagine that kalau you ada a long linear structure like this and kita nak consider for this molecule to form another van der Waals forces, untuk long linear molecule, dia ada a bigger surface area in contact with another molecules yang kita ada kat sini. Okay, so lagi banyak surface area in contact ataupun lagi besar surface area of contact yang you ada dengan another molecule, that means you can form more van der Waals forces. So more van der Waals forces means stronger intermolecular forces. Okay, and kalau you nak compare with this compound, for example, so kita ada branch molecule here and you can see that bila mana kita nak consider the electron density around this molecule, you can actually see molecule ni a bit, small and compact. So kalau you ada another molecule dalam you punya container, for example, you can see that actually dia cover a smaller surface area in contact. So lagi kecil surface area in contact, that means you have less van der Waals forces that can form here, means you have a weaker intermolecular forces. So the thing is, for the questions that we have for number 1 here, basically dia tengah discuss the factor of branching. So the general idea is that lagi banyak branch yang you ada, so molecule you akan dapat a smaller surface area in contact with another molecule. So because of that, less van der Waals forces will form, means you have a weaker intermolecular forces. So by this, if we want to discuss the answer, ataupun you need to explain your answer. So first, sila jawab soalan accordingly. Soalan minta you susun in the order of increasing boiling point. So you kena susun daripada smallest boiling point yang you boleh predict to the highest boiling point. And macam yang kita dah discuss tadi, weaker macam yang kita dah discuss tadi, weaker intermolecular forces means you have smaller boiling point. So for this one here, so I susun my answer like this, of which I akan susun 2244 tetramethylheptane followed by 4 ethyl-heptane and nonate. Okay, so I letak koma and then I letak kat tepi reference. This is in the order of increasing boiling point. So this is actually the easiest way untuk you write down your answer without, and then at the same time you kurangkan you punya minor mistakes. So by this, you can explain first, kenapa nonane has the highest boiling point, and then kenapa you punya 2244 tetramethylheptane will have the lowest boiling point. Okay, so for this, you can say that nonane has the highest boiling point due to its structure, which is the other long linear structure that can provide more surface area in contact with another molecule. And macam yang kita dah go through tadi, so kalau you ada more surface area in contact with another molecule, you can actually imagine you have more intermolecular forces that happen ataupun that exist between those molecules. So more intermolecular forces means stronger intermolecular forces. Okay, and for this one here, 2244 tetramethylpentane has the lowest boiling point compared to 2-ethyl-heptane. And the reason why, sebab you punya 2244 tetramethylheptane has more branch and has a smaller surface area in contact with other molecules. Okay, sebab lagi sikit surface area in contact means tak banyak intermolecular forces that can actually exist between those molecules. So that's why you have the weakest intermolecular forces among these three. Okay, so what are the things yang kita boleh consider untuk you jawab soalan macam ni? So kalau you dapat molecular formula, kalau you dapat nama as the structure, kalau you dapat nama of the compound, the easiest way for you to imagine is by converting daripada nama kepada structure. So by that, you can actually see the differences between these three compounds yang kita ada. Okay, so that would be the first questions for tonight. So let's continue for the second questions. Okay, so for this one here, kita akan compare the trend of boiling points for cyclohexanol, 2,3-dimethyl-1-butanol, 4-methyl-1-pentanol, and 1-hexanol. Okay, so of which these three, kalau you tengok nama dia je, pretty sure that you tahu, these four, pretty sure that you nampak all of those four compound are actually alcohol. Okay, so kalau alcohol, for sure you boleh form hydrogen bond. And kalau you check, hydrogen bond is kind of like the strongest intermolecular forces yang you boleh consider. Okay, so by that, bila mana you ada this structure, macam biasa, always check the number of carbon. Okay, always check the number of carbon yang you ada. So untuk cyclohexanol, so kita ada hexanol in a cyclic structure, so hexane 6 carbon. Untuk 2,3-dimethyl-1-butanol, kita ada butanol, so means you ada 4 carbon here, and then 2,3-dimethyl means kita akan tambah 2 carbon. Okay, so by that, you akan ada 6 carbon juga in total. So untuk 4-methyl-1-pentanol, so pentanol means you ada 5 carbon here, and then kita akan ada satu substituents methyl group dekat carbon nombor 4. So 5 campur 1, 6. And then last one, kita ada 1-hexanol. So kita ada 6 carbon. So all of these four actually kita ada 6 carbon. So actually argument kita bukanlah sebab molecular weight, tapi mesti sebab ada factors. Okay, so bila mana you lukis structure yang you ada, macam biasa I always emphasize on the drawing. So by this you can actually see, it's kind of like similar to what we have discussed previously. Okay, of which on how the effect of branching can actually affect you punya intermolecular forces. Sebab each of them have one hydroxyl group. Okay, so kalau untuk the three yang I highlight kat sini, obviously you can see lagi banyak branch means kita ada smaller surface area in contact. So tak banyak intermolecular forces means you have a weaker intermolecular forces. Okay, that is general idea that we have for these three yang I highlight kat sini. But then again, for now, kita ada additional cyclic structure. Okay, so bila mana you nak consider sama ada chain structure ataupun cyclic structure that will have stronger intermolecular forces, you should know you punya ring structure here, it's kind of like you can imagine it as someone yang boleh susun macam ni, and macam ni. So actually, ring structure have a more compact structure compared to long linear structure. Okay, so by that, in other words, kalau you ada the same number of carbon, but one of them is cyclic and one of them is a straight chain, cyclic structure will have stronger intermolecular forces. Sebab arrangement of molecules for a cyclic structure, dia lagi compact daripada linear structure. Means you boleh susun you punya ring structure tu rapat-rapat. Okay, so lagi better at arrangement, basically. Okay, lagi banyak yang you boleh susun, lagi compact you punya arrangement, that means you have a stronger intermolecular forces. So by this, that's why bila mana kita nak susun in terms of the order for increasing boiling point, we can say that cyclohexanol will have the highest boiling point, followed by 1-hexanol, 4-methyl 1-pentanol, and 2,3-dimethyl 1-butanol. Okay, and the reason why, sebab cyclohexanol has a ring structure, then can provide more contact surface area than 1-hexanol. Okay, sebab cyclohexanol can pack more tightly together. You actually boleh arrange ataupun compound tu can arrange themselves in a more compact positions. So lagi compact means lagi kuat intermolecular forces yang you ada sebab molecule you rapat dengan each other. Okay, and then followed by that, kita akan explain kenapa 1-hexanol has a higher boiling point than these two. So 1-hexanol has long linear shape ataupun long linear structure. So you can see here, panjang. Okay, so by that, it has more surface area in contact with another molecule. So lagi banyak surface area in contact means a stronger van der Waals forces. Okay, and bila mana you compare these two, it's pretty clear cut. This one is more, lagi structure dia, kalau kita consider electron density yang kita ada, dia macam bulat-bulat sikit kan, compared to di satu branch. So by this, you can say that this molecule here lagi banyak branch, so that means you actually provide less surface area in contact with another molecules. Okay, so that's why you punya 2,3-dimethyl 1-butanol here will have lowest boiling point among these four. Okay, so basically we are actually implying the same step. Kalau you dapat nama, susah untuk you imagine. First, lukis structure yang you ada, and then double check the number of carbon yang you ada. Okay, after that barulah you boleh nampak clearly macam mana you nak justify your answer. Okay, and let's continue to the third question for the night, which is on how we're going to arrange pentanol, 2,3-pentanediol, and pentane in the order of decreasing solubility. Okay, so macam yang I cakap previously, solubility is basically the ability of a species to form intermolecular forces with solvent molecule. So sekarang bila mana you tengok compound yang you ada, pentanol, pentanediol, and pentane, you tahu these two is alcohol and this one is alkene. So actually for this question here, we are actually discussing on how two different functional group, alkane versus alcohol, which one of them can actually dissolve in water. For example, kalau you nak pilih water as your solvent. So by this, for sure you tahu syarat untuk you form hydrogen bond mesti ada fluorine, oxygen ataupun nitrogen yang bonded with hydrogen. So untuk alcohol, basically kita consider you ada oxygen that bonded with hydrogen. So the structure here actually can form hydrogen bond with water. So by that, you patut aware semua alcohol can form hydrogen bond with water sebab kita ada hydroxyl group. And for alkane, obviously you cannot form hydrogen bond with water sebab basically you ada CH bond je throughout you punya molecule. Okay, so by that, you punya alkane cannot be dissolved in water sebab it cannot form hydrogen bond with water. Okay, but the comparison between pentanol and 2,3-pentanol diol. So untuk pentanol kita ada satu hydroxyl group dekat terminal carbon, while untuk 2,3-pentanediol you ada dua hydroxyl group. Okay, and since kita consider kalau dia ada hydroxyl group boleh form hydrogen bond with water. Kalau ada lagi banyak hydroxyl group, bukan ke lagi banyak hydrogen bond yang you boleh form in water? That's the thing. Okay, so by this you should know 2,3-pentanediol is the most soluble compound among these three sebab dia ada banyak hydroxyl group that can form hydrogen bond with water. But then again, soalan minta you susun in the decreasing order of solubility. So you kena susun according to what the question wants. Since the soalan wants decreasing order of solubility, so you letaklah yang paling soluble tu dekat sini. Okay, followed by pentanol and pentane. And then label your answer decreasing solubility. Okay, kalau you susun terbalik, salah. Sebab you tak menjawab soalan. That's how it works. Okay, so by this, as we agree earlier, 2,3-pentanediol has the highest solubility sebab it has more hydroxyl group that can form hydrogen bond with water. Dia ada dua hydroxyl group. So by that, dia boleh form dua hydrogen bond per molecule. Okay, tapi untuk pentanol, pentanol can only form one hydrogen bond per molecule. But then again, pentanol is more soluble than pentane sebab pentanol has hydroxyl group that can form hydrogen bond with water. Okay, so this is how we arrange our answer. Basically, you tengok dulu apa yang you ada. And this one, it's pretty easy sebab basically you ada the same number of carbon, pink, for each three of this, and then by that bila mana you check you punya structure, the differences is either you nak compare antara alkane dan juga alcohol and the number of hydroxyl group yang ada dalam you punya structure. Wajib ke buat arrow? I mean, isn't it better kalau you buat arrow sebab barulah examiner tu nampak clearly dengan jelas macam mana you susun you punya jawapan. Or actually, you can use inequality sign untuk you punya jawapan. But then again, if you are not good with maths, let's go for the safer method lah. Okay? So, I guess we akan stop kejap kat sini for a small break session. Nanti kita akan continue with acidity.
Okay, thank you, Miss Jana. So, the rest okay kah? Still okay? Are you still with us? If you're still with us, cuba respon sedikit dalam ruangan komen. Give some love to our facilitator tonight. Mantap. Okay. Sekarang ni kita akan take a very short break. Tapi short break ini kita mau buat sedikit activity quizzes. Okay. So are you guys ready? Are you guys ready? Are you guys ready for quizzes? Alright, okay. Kita akan ada pemenang So you need to try your very best to do your best for this quizzes. So I'm gonna present the quizzes now. Okay. Semua boleh nampak quizzes? Boleh start joining now, guys. Okay. Come on guys. Okay, kita baru ada satu partisipan. Kita akan mulakan. Bila kita dapat ramai lagi partisipan, kita akan mulakan our quizzes. Alright. Okay, 30 participants, 32. Come on, come on. Wow, semangat lah semua, semuanya semangat. Wow, 109 participant. Hebatlah kamu ni. Come on. Kita bawa lagi ramai-ramai masuk quizzes. Kita santai-santai saja malam ni, tidak perlu stres, okay? Kita belajar sampai kita bersantai-santai. Yang penting ilmu tu sampai, betul atau tidak? So, cuba kita hashtag sedikit, santai tapi sampai. Alright, once we reach 200, kita akan mula, okay? Once we reach 200 participant di dalam quizzes, kita akan mulakan. Kita tak boleh tunggu terlampau lama sebab ada banyak lagi yang perlu disampaikan oleh Miss Jana. Come on guys, come on guys. Macam jualan tu pula kan dalam TikTok. Walaupun sini tidak ada TikTok juga nih. Semangat-semangat. Semangat untuk PSPM. Yes, santai tapi sampai. Dari Nur Ermawati. Izwan. Yes, yes. Jason. Yes, yes. Irfan. Mantap. Sudah 200. Okay. Are you guys ready? Kita akan mulakan kita punya pertandingan quizzes untuk episod 1 SPKA ke bintang ke babong. Kita akan mulakan sekarang. Come on guys, santai tapi sampai. Malam ni kita belajar quizzes, sampai ilmu dia. Okay? Kalau ada yang guna music boleh sekarang ada cuba bagi tahu kawan komen. Wow. Wow. Alright. Siapakah pemenang dia? Man. Siapa Man? Nombor 1 Man, nombor 2 Asmir K11, nombor 3 Zarfan. Okay? So tolong nanti identify yourself. Kita ada Man, Asmir K11 dan juga Zarfan. Tolong PM tepi nanti ya, ataupun identify yourself di dalam ruangan komen. Anda adalah top 3 for our quizzes for tonight. Berikan tepukan yang gemuruh everyone. Wow, mantap sekali, mantap sekali. Alright. Kita akan teruskan lagi sesi kita bersama dengan Miss Jana. Okay, she will be telling you more about physical properties. Okay, are you guys ready? Kalau ready, tolong shout out sedikit di ruangan komen live chat. Are you ready? Are you ready? All right. I think without further ado, over to you again, Miss Jana.
Okay, so let's continue to where we stopped just now. But then again, I would like to remind you, untuk siapa yang menang tadi, make sure you identify yourself in the group chat ataupun you PM one of us. It's either you PM Mr. Byron, Mr. Shazwan or me as a winner. Sebab kalau tak nanti hadiah you orang lain yang ambil. Okay? So let's continue to the next physical property that we're going to discuss for tonight, which is acidity. So the thing is, last semester, kita cover a lot of ideas and a lot of concept regarding acidity. For example, you actually define acid in 3 terms. You either guna Lewis theory, Bronsted-Lawrence theory ataupun Arrhenius theory. Tapi kan, those of things macam banyak sangat nak cover kan? But the easiest way for you to imagine how does acidity works ataupun how we can identify sama ada we ada acid ataupun tak. So paling senang is basically you tengok you punya compound and consider adakah you punya species ada ability untuk release proton ataupun tak. Okay, so that means kita actually consider kalau you punya species ada ability to release its proton, that means you have acidic compound. So the easier your molecule to release proton, that means you have more acidic compound. Okay, so basically we go back to the basic idea macam mana kita nak determine acidity is based on the value of pH. But then again, you should know pH is just negative log concentration of proton. So that means lagi banyak concentration of proton that would release during the dissociation, pH you jadi lagi rendah, means you have acidic species. Okay? Or for this one here, paling senang, lagi banyak you punya molecules can release its proton, means you have a really acidic compound. So the thing is, bila mana kita nak discuss how acidic your species can be, you are actually consider between the two factors. Sama ada kita akan consider inductive effect ataupun resonant effect. But for now, let's take a look at the first factor yang kita akan cover, which is inductive effect. So for this one here, untuk inductive effect, actually we are observing the patterns of electron density around you punya structure. So pretty sure that at this stage, you dah well aware on the concept of electron donating group ataupun electron withdrawing group. Okay, so untuk electron withdrawing group, basically this is a group of structure that has the ability to withdraw electrons toward itself. That's why nama dia withdrawing group. So dia actually boleh withdraw electrons ataupun tarik electrons toward itself. Okay, and most of the time untuk electron withdrawing group, you akan jumpa very electronegative species such as group 16 and group 17. Okay, so for this one here, kalau ada electron withdrawing group dalam you punya structure, so contohnya kat sini, I choose carboxylic acid pair up with electron withdrawing group. Okay, so for this one here, you should know bila mana you nak release acid, so kita ada hydroxyl group kat sini kan. So basically, kalau you punya molecule able to break the OH bond that we have here, and then kita akan release proton in the while, so you akan form a carboxylate ion. Okay, and bila mana you tengok structure of carboxylate ion yang kita ada kat sini, so you ada oxygen with extra electrons here. Okay, and you should know you akan delocalize you punya electrons between two oxygen atom here. Okay, bila mana you form carboxylate ion, you akan delocalize your electron between two oxygen atom here. And consider this, kalau you form a very stable conjugate base, that means dissociation of proton can happen nicely. Ataupun you punya conjugate base ni, kalau dia stable, dia akan long live. That means you punya carboxylic ion ni susah untuk dia attack balik you punya proton, and you akan buat a reverse reaction of which you akan produce balik you punya carboxylic acid. So the thing is, if we want the species to show its acidic property, it need to release high concentration of proton. Okay, so of which you kena make sure tak ada orang lain yang usik proton kat sini to show its acidic property. So in order to do that, you actually kena consider the stability of conjugate base yang you ada. So anything that can stabilize your conjugate base will actually help during the dissociation process. So why this is important? Sebab bila mana you consider you ada banyak electron density kat sini, so electron density means you have a very reactive compound. Okay, kalau lagi banyak electrons yang berkumpul dekat satu tempat, means lagi reactive compound yang you ada. So the thing is, kalau actually we can withdraw some of the electrons away from this position here, so contohnya kita add on electron withdrawing group kat sini. So as per name, it can withdraw the electrons density toward itself. So electron density you tak lagi always concentrated for this region here. Okay, electron density you start to spread out towards electron withdrawing group. So actually, in other words, we are reducing the electron density around the carboxylate ion. So that's why it became less reactive. So kalau dia less reactive, dia tak banyak opportunity untuk attack dia punya proton. That's why structure ni stable. Okay, so that's why bila mana you go through your notes, you can actually see this statement here. Electron withdrawing group actually stabilize the conjugate base that is formed. Sebab it reduce the electron density around the reactive side of your compound. So kalau kita dapat reduce electron density here, you can actually form a very stable conjugate base. So stable conjugate base means you have a long-lived conjugate base. And dia tak reactive sangat. Okay, so bila mana you ada the factor of electron withdrawing group that present in your structure, also consider the position, number and electronegativity of electron withdrawing group yang you jumpa. Okay, so I think this is a really clear cut macam mana you nak consider the three factors that I highlight here. So kalau position lagi dekat electron withdrawing group you dengan you punya carboxylic ion, dia akan bagi a greater effect of withdrawing electron. Okay, and kalau lagi banyak electron withdrawing group yang you ada, means dia lagi banyak ability untuk tarik electrons toward itself. And kalau you guna a very electronegative species as electron withdrawing group, so that means you ada species yang boleh tarik banyak electron density toward itself. Sebab at this rate, you can consider electronegativity is the ability of a species to attract electrons toward itself. Okay, so more electronegative atom means dia ada better ability at attracting electrons toward itself. So by that, lagi banyak electron density yang akan tertarik dekat you punya electron withdrawing group. So kita boleh kurangkan electron density around this region here. Okay, so bila mana you ada electron withdrawing group, sila consider also the position, number and electronegativity of a species yang you akan jumpa. Okay, so that is for electron withdrawing group. So continue to the next one. What if kalau I letak electron donating group? It's not wrong, but it's not right either. Sebab bila mana you ada electron donating group, contohnya electron donating group yang you akan always jumpa is actually alkyl group. So kalau you ada alkyl group ataupun electron donating group kat sini, as per name itself, it's donating electron. Okay, ada satu benda yang you kena, tak ada dua benda you kena consider bila mana kita ada electron donating group kat sini. Okay, so first you are considering how easy for you to break the OH bond and how stable you punya conjugate base yang you akan form. Okay, these two are actually the two things yang you kena consider bila mana you tengok you punya structure. So, lagi senang untuk you putuskan ikatan antara oksigen dan juga hidrogen, maksudnya lagi senang untuk you release proton, means you have more acidic molecule. Okay, and at the same time, kalau lagi stable conjugate base yang you ada, means you punya conjugate base tu tak reaktif sangat, dia takkan attack mana-mana proton around it. So, by that, you akan ada banyak concentration of proton, means more acidic. Okay, so bila mana kita ada electron donating group in here, dia bukan sekadar increase electron density to the neighboring side. So that means dia akan increase you punya electron density kat sini. That's one thing. And another thing is that dia akan also increase the electron density in your OH bond. Okay, so here's the catch. Lagi banyak electron density accumulated in OH bond, lagi kuat OH bond yang you akan ada. So, kalau you punya OH bond tu jadi sangat kuat, susahlah untuk you putuskan ikatan ni kan. That means susahlah untuk dia release proton. So, that's why kalau you ada electron donating group, susah actually untuk that species to release its proton. That is the first thing. Okay? But then again, bila mana boleh putus bond antara oksigen dan juga hidrogen, now you have a very unstable structure of conjugate base. Sebab you kena ingat, extra electron on oxygen, making this side here become very reactive. Okay, kalau kita consider the factor of electron withdrawing group tadi, kita actually boleh tarik elektron keluar daripada reaction site kat sini. So kalau dia kurang electron density, dia tak banyak electron, means dia kurang reactive. But this one here adalah kita ada a very reactive species, extra electron on oxygen. And at the same time, kita ada electron donating group. you have a lot of electrons being pushed toward this reaction site here. Okay, so you ada banyak electron density yang datang daripada electron donating group, and you ada banyak electron kat sini. So extra electrons means very reactive. Okay, kalau lagi reaktif, you punya conjugate base yang you ada kat sini, you punya electron density berkumpul dekat satu tempat yang sama. So actually, you punya carboxylic ion ni ada higher tendency untuk attack balik proton yang dia dah lepaskan tadi. So instead of you dissociate proton, you akan dapat balik original state of carboxylic acid yang you ada. Okay, so that's why it's not really favorable for you to have electron donating group bila mana kita nak consider acidity of the species. Okay, to summarize, electron withdrawing group actually increase the acidity of a species yang you ada, tapi you akan dapat opposite effect bila mana you tambah electron donating group dalam you punya structure. Okay, so by that, let's continue to the second factor, which is resonant effect. Okay, pretty sure that you dah jumpa the words resonant before. Resonant is basically just another interpretations of the molecule for in terms of electron density around your punya structure. So by this, you should know resonance structure can actually help to stabilize the conjugate base. Macam yang I dah bagi tahu tadi, sebenarnya kalau actually kita boleh disperse ataupun you boleh alihkan you punya electron density daripada berkumpul dekat satu tempat je, you can actually make your molecule less reactive. So less reactive means more stable. So by that, kita tengok the resonance structure of carboxylic acid. So for this one here, bila mana you dissociate carboxylic acid, you akan form carboxylic ion. So when you check the resonance structure of carboxylic ion, so you can see that the electron delocalize between two oxygen atom yang kita ada kat sini. So you ada extra electron here, so you boleh push masuk buat bond kat sini. And bila mana you ada electron density that pushing towards your carbon here, electron kat sini akan experience repulsion, so dia akan lari keluar, pergi dekat oxygen. So you akan dapat the second resonance structure kita ada kat sini. And bila mana you ada electrons kat sini, so obviously dia boleh push masuk balik buat bond, and dia akan push electron density ni keluar. So you akan dapat the first original structure of resonance. Okay, so as you can see here, you have electrons that are actually being delocalized between two oxygen atom. And why this is actually a very good thing? Sebab basically, electron you tak berkumpul dekat satu tempat je. So, it will make your oxygen less reactive. That is the first thing. But then again, you punya electrons are actually being delocalized between two oxygen atom. So, you kena ingat, oxygen is the top second most electronegative atom. And the thing is, bila mana you bagi extra electrons dekat electronegative species, that is a really, really good thing. Sebab oxygen is really good at handling extra electrons due to its electronegativity. Basically, you give the job to the specialist. Okay, you bagi species yang memang boleh handle electrons daripada awal due to its electronegativity. So that's why carboxylic acid is quite acidic. Okay, sebab kita ada carboxylic ion yang boleh delocalize electron between two oxygen atom, which is a very electronegative atom. Okay, and bila mana kita nak compare in terms of resonance, ada lagi satu structure yang you boleh consider, which is phenol. Okay, so phenol is basically a hydroxyl compound. And again, bila mana you ada hydroxyl group, you boleh consider the possibility for this species to release its proton. So bila mana you ada hydroxyl group here, and dia release proton, you akan form phenoxide ion. And the thing is, bila mana you tengok structure yang kita ada kat sini, kita ada benzene ring. So the thing is, you can actually delocalize extra electrons here into the benzene ring. So this is actually the delocalization of electron in benzene ring. So daripada electron kat sini, dia akan form double bond here, push this electron density away. So dia akan move as the electrons yang kat sini. Okay, and the same thing goes by, dia push electron here, dia akan keluar kat sini, push electron here, keluar kat sana, push electron here, dia akan keluar balik dapat you punya original structure. Basically, this is actually shows the delocalizations of electron in phenoxide happen around the ring. Okay, dalam you punya benzene ring ni, electron boleh delocalize. Okay, So by this, actually, you are shifting the electrons daripada fokus on oxygen sahaja, dia akan delocalize inside your ring. Which is, isn't it a good thing? Sebab actually kita spread out the burdens to everyone. So by this, you should know why phenol is acidic. Sebab kita ada electrons that can be delocalized throughout the benzene ring. Okay? So that is the key things yang kita kena aware. First, check dulu sama ada you ada EDG ataupun EWG in your structure. Second, consider the resonance structure that can form for your conjugate base. Okay? So by that, let's take a look at the first questions that we have here. So we need to compare the acidity between phenol, water, ethanoic acid, and ethanol. Provide suitable justification for the arrangement in the order of increasing acidity. So basically, kita kena pick which one is the most acidic among these four components you ada. Okay, so to make things easy, I actually visualize the structure for you. So this one here, kita ada dissociations of proton for phenol, water, ethanoic acid, and ethanol. Okay, so kalau you ada phenol, dia release proton, you akan form phenoxide ion. Okay, that is the conjugate base untuk acid yang you ada. What is the example of electron donating group? Okay, so basically electron donating group paling senang yang you boleh imagine adalah alkyl group. You punya hydrocarbon. Okay, that would be the best electron donating group yang you ada. Okay, ataupun kalau you ada species with lone pair. So that's the thing. Electron donating group, it can be either alkyl group, sebab tak banyak differences in terms of electronegativity between carbon and hydrogen. That's why you boleh guna electron tu ataupun you boleh push electron tu here and there. Another one is you ada lone pair. So lone pair is basically unbounded electrons and it's a quite really good electrons yang you actually boleh move around sebab kita tak bounded you punya electrons tu with another atom. Okay, so you tengok je you punya structure. Kalau you ada extra alkyl group ataupun you ada species with lone pair, for example, then you can consider you have electron donating group. Okay, so let's continue with this one here. So kita ada hydroxide ion as the conjugate base for your water, and then kita ada ethanoate ion untuk conjugate base for your ethanoic acid, and ethoxide ion conjugate base untuk ethanol. Okay, so macam yang kita dah go through tadi, obviously, you kena consider carboxylic acid is the most acidic compound yang you akan jumpa. Sebab satu, sangat senang untuk dia release its proton sebab kita ada delocalizations of electron. That is the first thing. And the thing is, untuk you punya carboxylic acid kat sini, so kita ada carbon bonded with oxygen. So you ada carbon with pi bond. So the thing is about carbon in pi bond is actually a very electron withdrawing kind of vibes. So because of that, you have a really good combination for a structure that can actually form a stable conjugate base. Okay, disebabkan OH bond kat sini is pretty weak one, and at the same time you have a structure that can delocalize the electrons. So that's why bila mana you nak compare the acidity between alcohol, carboxylic acid dan juga phenol, carboxylic acid would be the best one. Okay, sebab carboxylic acid ada resonance stabilization due to the carboxylate ion. Okay, walaupun both phenoxide ion dan juga ethanoate ion can delocalize its electron. But then again, bila mana you tengok you punya phenoxide ion, the electrons are being delocalized by carbon. Okay, but for ethanoate ion ataupun carboxylate ion yang kita ada kat sini, the electrons are being delocalized by oxygen. So obviously, oxygen is more electronegative than carbon. So dia lagi better at handling those delocalization. So that's why bila mana you ada carboxylic acid, it is more acidic than phenol. Okay, so that is the first thing you can consider. And second, what about alcohol? Okay, but the thing is, alcohol is like the weakest acid that you could have. Kenapa? Sebab bila mana you tengok structure of alcohol yang kita ada kat sini, so the thing is, this is alkyl group kan? Tak ada apa-apa electronegative atom at all. So the thing is, actually this is alkyl group, so that means kita ada electron donating group. So you punya electron donating group kat sini, you kena aware dia pair up dengan oxygen. So oxygen is very electronegative. Dia actually tarik electrons toward itself. Okay, akan ada banyak electrons berkumpul kat sini, and at the same time you akan increase the electron density around your OH bond. Lagi banyak electron density around your OH bond, that means you punya OH bond tu sangat kuat. Sangat susah untuk you putuskan. So sangat susah actually for your ethanol to release its proton and form ethoxide ion. That is the first thing. It is really difficult for you to break the OH bond for alcohol. Okay, sebab kita ada alkyl group as electron donating group. And again, another one is that you kena consider bila mana kita ada ethoxide ion kat sini, this is very reactive. And pretty sure that actually you dah guna ethoxide ion a few times as a nucleophile. Kenapa? Sebab kita ada a very reactive species kat sini. Kita ada oxygen with extra electrons, itu dah very reactive. And at the same time, kita add on alkyl group on top of the reactive oxygen. So basically, you punya electron density semua akan shifted towards oxygen kat sini. So you punya oxygen ada banyak electrons. There are a lot of electron density that actually concentrated on this oxygen here, making it a very good nucleophile. Okay, kalau you ada banyak electron density on your oxygen kat sini, actually you punya species ataupun you punya structure kat sini becomes very reactive sebab you ada electrons yang banyak berkumpul dekat satu tempat. That's why dia very reactive. So instead of it stable ataupun wujud sebagai ethoxide ion, dia ada higher tendency untuk attack balik you punya hydroxinium ion kat sini, and you akan dapat balik, and you akan dapat balik you punya original structure of alcohol. So that means you punya alcohol sangat susah untuk release its proton. Okay? So let's consider this point when we discussing our answer. So the first one, we need to arrange in the order of increasing acidity. So macam yang kita dah cakap tadi, so ethanol is the weakest acid among them all. The reason why, sebab ethanol form ethoxide ion. Okay? And the presence of alkyl group ataupun the presence of electron donating group in the structure, making it less stable than other conjugate base yang you akan form. Okay? The electron donating group in your alcohol structure actually strengthen the OH bond yang you ada. That's why alcohol you sangat susah untuk release its proton. And kalau dia dapat release proton sekalipun, dia akan form a very unstable conjugate base. Okay? So that's why ethanol akan dapat title the weakest acid yang you akan ada. And then follow up by water, phenol and ethanoic acid would be the strongest species yang boleh release its proton. Okay? Ethanoic acid is the most acidic. So macam yang kita dah discuss tadi, electrons are delocalized between two oxygen atom in ethanoic ion. Okay? Basically, you pass your electrons to a very electronegative species. Isn't that a good thing? Okay? And consider that bila mana kita nak compare dengan phenol, phenol is less acidic than ethanoic acid. Since for phenol, electrons are delocalized throughout the benzene ring. So instead of electronegative species yang handle you punya extra electrons tu, tapi carbon. And you know for sure, carbon is not really that electronegative. Okay, they're quite neutral. So by that, you should know oxygen is better at handling extra electrons than carbon. So that's why, walaupun phenol ada banyak resonance structure, maksudnya dia lagi better at delocalizing its electron. Tapi since the one yang in charge of delocalization is less electronegative, that's why you punya phenol is less acidic than carboxylic acid. Okay, so that is for question number 4. So continue to the next one. So let's take a look at the three structural formula of carboxylic acid that we have. And we need to arrange in the order of increasing acidity. So by this, bila mana you tengok you punya structure. So this is A, B, and C. Okay, so for this one here, you ada semua benzene ring, of which you're really good at the localization. But bila mana you check carefully, untuk structure of A, you have a basic structure of benzene and carboxylic acid. Okay, nothing much. And bila mana you tengok structure B, kita ada presence of chlorine. Chlorine is very electronegative, so you know for sure this is you punya electron withdrawing group. Okay, and bila mana you check the third structure yang kita ada kat sini, kita ada methyl group at para position. So macam yang I cakap tadi, any alkyl group is actually electron donating group. Okay, so as what discussed earlier, obviously species with electron donating group is very acidic. Sebab dia akan tarik electrons toward itself, electron you tak berkumpul dekat satu tempat. Tapi kalau you ada electron donating group, dia akan jadi less acidic. Sebab instead of dia tarik elektron, dia bagi elektron dekat orang lain. So because of that, you strengthen the OH bond kat sini. And kalau dia dapat dissociate proton sekalipun, you akan form a very unstable conjugate base. So by this, obviously, the one with electron donating group akan dapat nombor 1, followed out by the neutral species yang kita ada kat sini, species yang tak ada EDG or EWG. And then the last one will be the species with EDG. Dia akan dapat nombor 3. Okay, so let's see on how we're going to discuss the answer. So you can simply say that kalau disebabkan dia dah label sini A, B and C, so you don't have to really redraw the structure lah for your answer. You boleh simply say that ikut label yang you dah guna. Okay, so for this one here, macam yang kita dah go through tadi, so carboxylic acid C followed out by A and B will have the most acidic species yang you ada. Okay, so by this you can simply say that structure B is the most acidic due to the presence of chlorine. So you boleh bagi tahu chlorine is actually electron withdrawing group. So the presence of chlorine will weaken the OH bond. Maksudnya kalau you ada chlorine dalam you punya structure, OH bond you akan jadi lemah atau senang putus. So kalau senang putus, senang untuk you release proton. So lagi banyak proton yang you boleh release, lagi acidic compound you. Okay, so that is why B will have the highest acidity among these three. Sebab kita ada electron withdrawing group. And bila mana kita continue comparing structure C and A, so A is pretty, nothing much going on here. You ada carboxyl group, you ada benzene. Tapi kalau you nak compare dengan C, so obviously kita ada methyl group, which is electron donating group. So you can say that structure C is less acidic due to the presence of methyl group yang you ada kat sini. So you boleh mention methyl group is electron donating group. So methyl group will strengthen the OH bond. Okay, macam yang kita dah go through tadi. So kalau you ada apa-apa species yang boleh strengthen the OH bond, sangat susah untuk you putuskan you punya OH bond tu. That means sangat susah untuk you punya compound to release its proton. So that's why it become the less acidic species. Okay, and one thing yang you kena take note in here, carboxylate ion ataupun the conjugate base yang you akan form throughout the dissociation reaction kat sini, dia akan destabilized by the presence of electron donating group. Okay, kalau you ada electron withdrawing group, dia akan increase you punya acidity. Kalau you ada electron donating group, dia akan decrease the acidity of the species. Okay, so let's continue to the last question for tonight. So kita ada chloroethanoic acid, kita ada ethanoic acid, kita ada ethanol, kita ada fluoroethanoic acid, kita ada difluoroethanoic acid. So the thing is, everything is carboxylic acid except one, alcohol. So for sure, you tahu which one is the weakest acid that we have here? Alcohol. Okay, so let's take a look at the structure yang kita ada. So the first one, which is you punya chloroethanoic acid. So basically, you ada carboxylic acid, and then dekat carbon dia, kita ada satu extra chlorine. Okay, so for this one here, for sure you tahu, by means, you know by heart. Chlorine is actually group 17, very electronegative. So you akan ada electron withdrawing group here. Okay, and then bila mana you compare dengan ethanoic acid, so for this one here, you ada methyl group extra, okay, ataupun you ada this alkyl group that attached to your carboxyl group. So kalau you ada alkyl group, for sure you know this is electron donating group. So kalau you compare between these two sekalipun, you patut aware, the one with chlorine is more acidic lah, sebab kita ada electron withdrawing group. And continue to the next one, which is you punya ethanol. So untuk you punya ethanol kat sini, kita ada ethyl group here. So basically this is your alkyl group. So kalau kita ada alkyl group, means you ada electron donating group. But then again, for sure, you know by heart, at this stage, alcohol will be the weakest acid yang you akan jumpa kat sini. Okay, and then next one, kita ada carboxylic acid with 1 fluorine. So you know for sure, fluorine is group 17 species. Kita ada fluorine, chlorine, bromine, iodine. So this one is fluorine, comes from group 17, very electronegative. So you ada electron withdrawing group here. And the last structure yang kita ada is basically you ada dua attachment of fluorine, EWG. Okay, so let's see the overall structure yang kita ada for tonight. So kalau you nak compare sekarang, for sure species with electron donating group will have higher acidity compared to species that pair up with electron donating group. That is one thing for sure. Okay, and kalau you nak compare between the three species that has attachment of electron withdrawing group kat sini, so kita ada satu with chlorine, satu with fluorine, and satu lagi dua attachment on fluorine. So by this, kalau you nak compare, kita compare antara chlorine dan juga fluorine. So for sure you know, comparing between these two, fluorine is more electronegative than chlorine. Okay, fluorine is the most electronegative atom that ever exists since today. So by this, you know by heart, kalau you ada fluorine, fluorine is the most electronegative atom. Maksudnya dia sangat-sangat electronegative, sangat kuat in terms of attracting electrons toward itself. So by rule, fluorine should have a better electron withdrawing ability than chlorine. So kalau you ada fluorine in your carboxylic acid structure, so carboxylic acid with fluorine will have higher acidity ataupun stronger acidity compared to species with chlorine. Okay, and now again, bila mana you compare these two, for sure, the one with more fluorine will have more electron withdrawing ability. Okay, so that is for electron withdrawing group. So next one is electron donating group attachment. So kat sini kita ada carboxylic acid with electron donating group and kita ada alcohol. But then again, dari awal lagi kita dah bagi tahu, alcohol is the weakest acid that you could have. So by this, the last position will be taken by ethanol. Okay, sebab kita ada electron donating group that attach directly to your hydroxyl group. And bila mana kita ada carboxylic acid kat sini, okay, you kena ingat, kalau kita ada double bond here, kita ada C double bond O, this is actually electron withdrawing group. You can actually withdraw electrons daripada OH bond kat sini, pergi dekat carbon oxygen structure kat sini. Okay, but then again, we have electron donating group here. So, you can actually release its proton, but it's better kalau you ada electron withdrawing group kat sini. Okay, so that is the general idea that we have for this question here. So let's take a look macam mana you nak susun jawapan you. Okay, and kalau lah you nak salin molecular formula ni pergi jawapan, tolonglah salin betul-betul. Make sure bilangan carbon, hydrogen, oxygen, chlorine and fluorine you betul-betul sama macam soalan. Tolonglah. Okay? So by this, kita dah tahu dari awal, the one with more fluorine akan ada highest acidity, while the one alcohol, you punya ethanol kat sini, akan ada less acidic species. So let's take a look at how we're going to discuss the answer. So first one, you can mention, ethanol is the weakest acid. Kenapa? Sebab kita ada ethyl group, which is electron donating group. Okay, and again, I would like to emphasize, please make sure you write down the full term that you use in your answer. So kalau electron donating group, tulislah betul-betul electron donating group dalam kurungan EDG. Okay, after you write down the correct phrase for the terms that you use, barulah you boleh simplify throughout you punya justification with short form. Okay, but before that, sila tulis the full phrases ataupun the full terms that you're going to use for your discussion. Okay, and then going back to here, we emphasize that the presence of ethyl group is actually electron donating group. Dia akan strengthen the OH bond. So kalau lagi kuat OH bond yang you ada, sangat susah untuk you putuskan ikatan tu, sangat susah untuk you punya alcohol release its proton. Okay? Miss, kalau nak assign letter boleh tak? Contohnya, boleh. Boleh. Tak salah. Tapi make sure you janganlah assign tu dekat kertas soalan je. You assign dekat jawapan juga. Okay? So untuk jawapan you, salin balik everything and then label A, B, C, D, E. Okay? Barulah you tulis in the order of increasing acidity. Okay? Jangan tulis dekat kertas soalan je. Tulis dekat kertas jawapan juga. Okay? So by this, that would be the discussion about alcohol. So continue to the next one. You can say that ethanoic acid is stronger than ethanol. The reason why? Sebab kita ada delocalization of electrons between two oxygen atom for ethanoate ion. So this will increase the stability of ethanoate ion that you form. Okay? So antara alcohol dan juga carboxylic acid, the big difference is that you ada electron density that can be delocalized between two oxygen atom. And bila mana kita nak consider the rest of the three structure yang kita ada, so macam yang kita dah tengok tadi, the rest three, semua tu ada attachment with electron withdrawing group. Okay, but then again, one of them use chlorine. Okay, so bila mana you ada chlorine, and macam yang kita dah go through tadi, chlorine is less electronegative than fluorine. So that's why electron withdrawing ability untuk fluorine better. So because of that, you can say that fluorine is more electronegative than chlorine. It has stronger electron withdrawing effect. Fluorine will stabilize the carboxylic ion better than chlorine. Okay, so that is how you argue you punya answer. The presence of more electronegative atom can actually withdraw electrons better. And the last one is actually the number of fluorine yang ada dalam you punya structure. So for this one here, you ada 2 fluorine and this one kita ada 1 fluorine. So obviously lagi banyak fluorine is better sebab you boleh increase the electron withdrawing effect. Okay, so this is how you should justify your answer. Okay, basically apa yang you kena buat kat sini, explain kenapa kat sini will have the weakest acidity among these 5 and then compare to the neighboring species yang kita ada and then compare among these 3 yang kita ada. Okay, but please make sure bila mana you buat comparison, you kena mention yang the weakest one apa, the strongest one apa, and then you can actually compare yang kat tengah-tengah tu in between them. Okay, make sure you explain clearly your answer ataupun the big differences between the compound yang you ada, and that is how you punya compound can actually give out different value of acidity. Okay, so I guess I shall stop at here. And I wish you guys all the best for your examination. Okay, semoga kalau keluar soalan physical property, you dapat jawab dengan baik and betul. Okay, so that's all from me.
Okay, thank you, Miss Jana, for the wonderful sharing session about physical properties. The recap, okay, recap about physical properties dalam organic chemistry khas untuk persediaan PSPM kamu. Okay, guys, thank you so much for your attention. So sebelum kita beredar, saya mahu kamu semua isi dahulu kehadiran. Ingat, kehadiran ini kita akan cari pemenang kumpulan tutorial yang mempunyai penyertaan yang tinggi ya, paling tinggi. Okey, cuba bolehkah klik link dalam grup tu? Kalau tidak boleh, kasih tahu. Dapatkah klik? Sekejap ya. Standby dulu. Isi dulu kehadiran guys. Cuba bagi tahu saya dulu, bolehkah klik link yang saya share dalam ruangan komen? Boleh klik kah? Attendance, check dalam ruangan komen, boleh tidak klik. Okey, sekejap ya. Okey, bersabar ya, Yoruben. Sekejap. Sementara menunggu, saya settlekan dulu ni. Okey, cuba try sekarang. Boleh klik. Kalau dapat klik, boleh isi. You alls isi. Nanti rugi ya, tidak menang nanti hadiah. Okey, sementara you alls mengisi. Saya mau bagi preview sedikit lah. Kita punya next episode ya. Okey, kita akan ada daripada Madam Reni, which is tomorrow. Tomorrow Madam Reni akan menyampaikan perkongsian mengenai tips-tips bagaimana kamu mau menjawab soalan yang berkaitan tentang chemical reaction daripada chapter 5, 6, 7 dan 8. Hydrocarbon, benzene, haloalkane dan hydroxy compound. So, jangan lepaskan peluang keemasan ini untuk bersama facilitator kita yang hebat, yang paling kecindan, Madam Reni. Okay? Ini esoklah. Alright. Kalau tidak ada apa-apa lagi kehadiran. Kalau ada rakan-rakan dari college lain, can you give shout out in the live chat and tell us where you from? College mana? Kalau ada yang bukan dari Labuan, kalau ada menyertai kami pada malam hari ini, can you give us some supports and tell us from where you are? Mantap. Mantap semuanya, mantap. Kita santai-santai sahaja, okey, santai tapi sampai. Okey. Again, kalau ada yang dari college yang lain, if you are still here, can you tell us where you're from? Alright. Small Su. Okay, hi daripada Pahang. Kita ada rakan daripada Kolej Matrikulasi Pahang. Thank you for your support. All the best for PSPM juga. Hi Ali, thank you Ali. Thank you for the support. Tim Sebayron, oh gitu. Santai tapi membantai. Wow, Gilbert. Ganasnya Gilbert. Kita bantai untuk dapat markah yang tinggi ya. Jangan kita bantai orang ya. Okay, Ryan. Dari KL. Dari Kuala Lumpur. Thank you. One days. From MMC. Oh, dari Melaka, okay. Hi, David Adul from Melaka Matriculation College. Thank you for your support. Firdaus. Alright. Okay, I would like to remind you tomorrow kita akan ada our next episode for our open lecture. Bersama-sama dengan seorang lagi facilitator yang hebat, Madam Reni. Dan kita akan tengok mengenai chemical reaction ke bintang ke babum. Gitu. Terengganu adakah college? Sherlock Holmes ni dari mana ni? Wow, mungkin dah buka, mungkin Terengganu sekarang. Tengah testing kot. Thank you juga semua. Thank you so much. See you guys again tomorrow. Tomorrow kita akan bersama-sama dengan Madam Reni dalam live ni sekarang. Kita bagi support. Okay, bawa lagi ramai kawan-kawan. Manalah tahu tutorial kamu akan menang kan pada akhir sesi SPKA ke bintang ke babum punya sesi. Okay, jangan lupa isi feedback form yang merupakan attendance. Thank you, Eric. Okay, so thank you so much for joining us tonight. Mungkin kalau ada yang tidak dapat join secara live, tolong bagi tahu yang lain. Rakaman akan ada dan kita akan sediakan portal untuk kamu akses lah our bahan untuk sesi SPKA ke bintang ke babum. Alright, so that's all for tonight, guys. Thank you very much. All the best and have a nice the rest of the day. Bye bye.